This video will go over some of the other functions in the Config.Js file that aren't the looks. Create change transition time. This function will create a trigger that changes the transition duration. The variable in quotations is the name of this transition time, and the number after it is the time in seconds. As you can see, you can use decimals here as well. You can add as many copies of this function as you need. Create change transition easing linear, bounce, symmetric Bezier, and Bezier. These functions change the transition easing function. An easing function changes how a transition progresses over time. A linear ease is the default and doesn't actually change anything. An example of a linear versus eased can be seen here. If we click Go, we can watch the cyan and the magenta boxes. The cyan box is a linear ease and the magenta box is a Bezier. A bounce ease makes the transition bounce a configurable number of times at the end of the transition, kind of like a drop ball. A Bezier ease is the same as what's shown here. These four numbers at the top of the page can be inserted as the four arguments to the command to get the same ease effect. A symmetric Bezier is a simpler form of a Bezier ease where the second control point is placed in position that mirrors the first control point. This makes the ease symmetric. When the ease is symmetric, it means it's doing the same thing as it's running forwards or backwards. Create look fit fudge. FitFudge controls the aspect ratio of the video and keyer zones. Let's use this picture of a drill as our source and this sign as our destination. A FitFudge of 0 causes the engine to take exactly the source area configured and place it exactly in the destination area configured. If the aspect ratios are not the same, the video will be smushed or skewed. This is sometimes called stretch mode. A FitFudge of 1 will tell the engine to keep the aspect ratio from the source, cropping the top and bottom, or left and right, of the input as needed. The entire destination area will be filled, but parts of the source may be cropped off. This is sometimes called fill mode. A FitFudge of -1 will tell the engine to keep the aspect ratio from the source, shrinking the top and bottom, or left and right, of the destination area as needed. The entire source will be used, but part of the destination area will not be filled in, and will show any zones at a lower Z order. This is sometimes called best fit mode, except that the VP will not fill the unused space with black. FitFudge is a decimal number, meaning you can pick fractions anywhere between -1 and +1. A fractional value will do a mixture. For example, with the differing source and destination aspect ratios, a FitFudge value of 0.75 will pick an aspect ratio of about 75% of the way between FitFudge 0 and FitFudge 1. In other words, it will be skewed about 25%, but will hold about 75% of the aspect ratio. You should experiment with different values to see which value looks the best. Negative values are advised against, as they will leave holes in the canvas. 0 and 1 can be assured to do exactly what was previously stated. DMP is VM5 and DMP source number. These variables control the VMAX5 mode for the DMP zone. By default, the DMP zone will not have VMAX5 enabled and will use source number 5. If the DMP is using a different source number, uncomment the second line and change the 5 to the correct source number. To enable VMAX5 in the JavaScript engine, uncomment the first line, the DMP is VM5. And don't forget to change all the other config as laid out in DD 388.48.79. Note that you can set the variable back to false temporarily to turn off VMAX5 without having to undo the other config. When VMAX5 is disabled, the DMP zone is at the bottom of the Z order and keying is disabled. When it is turned on, the DMP zone is at the top of the Z order and keying is enabled. Presently, there is no way to change this dynamically during the show. A future look package release will make that possible. Key and fill refers to two video signals working together to create a third combined image. It is a way of incorporating full transparency support to overlay graphics on top of another signal, like a live camera feed for a live event. An alpha, or linear key, sends a separate video signal that contains the key or transparency information. This key video signal looks like a grayscale image and defines the exact transparency the fill signal is supposed to apply as an overlay on the background. The fill video signal contains the graphical information that is desired to be overlaid on top of another signal. If we look here, this is what a key might look like. You can see the grayscale looking image here. This is what our fill signal might look like. And then if we combine that with live video, here is what that may look like. SDI key and fill refers to having two separate SDI feeds outputting from a DMP or third-party player. One is a key signal that tells a video processor which parts to cut out, and the other is what to fill in that cutout part with. This method for key and fill is a broadcast standard. The VP-6000 is capable of receiving these signals, as well as most industry processors. The DisplayPort key and fill refers to having two separate display ports, or HDMI or DVI, outputs from a DMP. One signal carries the key, and another carries the fill, exactly like the SDI key and fill described before. This is typically used when the DMP is feeding a third-party processor like a spider or an analog way. This is because VP-6000 is not capable of receiving this kind of input, as we only have one DisplayPort input when two are needed. Another scenario where we might use the DisplayPort key and fill is when we have a DMP-8000 that has DisplayPort outputs instead of SDI outputs. VMAX5 refers to a proprietary extension to DisplayPort, where we send both key and fill down a single DisplayPort cable. Only the VP-6000 is capable of receiving this signal, and only the DMP-8000 is capable of producing it. It serves the same purpose listed before, but can do so on a single signal path, leaving more inputs open for the customers to use for other devices. Boot up default looks. This function is used to configure the engine to execute certain triggers automatically when it starts up. This can be used to configure startup looks. Simply copy the run trigger line, remove the comment, and change the trigger name to a valid trigger name string. You can execute as many triggers as you like. Now let's get into dual video specifics. Create change input A is exactly the same as create change input B here, except that A operates on video zone A, and B operates on video zone B. Let's just focus on A first. A can mean two different things here. The A in the command part, such as create change source A, means it operates on video zone A. The A in the trigger name, such as PIPA source A, means source A. Create enable video A transitions the video zone on, making it visible. Create disable video A transitions the video zone off, making it invisible. Create change source A transitions the video zone to a different source. If the video zone is disabled, no visible change will be seen, but when the zone is re-enabled, it will be showing the new source. Create change input A transitions the video zone to a different source and enables it if disabled. It is logically the same as create change source A, followed by create enable video A. One thing to note, the DMP zone is always active, even if you can't see it. It may be covered by a full screen video zone, or it may be transparent because the VMAX5 is enabled and the DMP isn't playing anything. Regardless, the zone is always active and always there and always in the same position. Single video specifics. This sets up some JavaScript variables to use later on in the config script. Simply replace A with B in all the previous functions to edit zone B. Single video with aux specifics. The create aux look full screen, aux look PIP, aux enable, and aux disable are the same as create look full screen, look PIP, enable video, and disable video respectively. The only difference being that these functions operate on the key/fill zone.